Okay, the last session we discussed about the data types. We discussed that C supports four basic data types. C supports four basic data types. One is char, integer, float, and double, represented as char char, that is character, and int for integer, float for real values, actually double for real values with double precision. So we have char, int, float, double. So these are the four basic data types. Of course, you can use qualifiers like signed, unsigned to differentiate between signed numbers and unsigned numbers. And also you can increase the length, decrease the length using short and long. Short and long. And how you apply the qualifiers, it may vary from compiler to compiler, but generally we go with the long integers also. But we have seen in the previous case, for our compiler, long int and int both occupy the same space, so there is no use of it. So if the long int occupies 2 bytes and the long int occupies 4 bytes, then it will be useful. Or int occupies 4 bytes and long int occupies 8 bytes, then it will be useful because the range of numbers which you can represent is going to increase. So, but it varies from compiler to compiler. Which version of the language specification the compiler is using, like that it may vary. So in this session, we'll discuss about the fundamentals called as constants, variables, and other things like enumeration, escape sequences. The most important among this is variables, and also constants. So constants, variables, we are going to discuss in this session. So constant is an identifier the constant is an identifier whose value doesn't change during the execution of the program. So constant is an identifier whose value doesn't change during the execution of the program. That means its value once initialized will remain the same. Once it takes some value, the value remains the same throughout the program. You cannot change it. So it's an identifier. So in the case of C language, all the valid names are nothing but the valid identifiers. Valid names are nothing but the valid identifiers. There are three types of constants in C: literal constants, constants declared using the const keyword or reserved word, and then the symbolic constants, which are defined using hash define. Literal constants exist independent of any identifier. Literal constants exist independent of any identifier, and there are four literal constants in C: integer constants, floating point constants, character constants, and string constants. So you don't need to declare it as an identifier. Don't need to declare it as an identifier. In fact, if you observe carefully, it will not come under actually our definition. Will not actually come under our definition, but nevertheless, they are considered as constants. They are called as literal constants because they appear or they are used as you are writing them. As you write them, they will be used. That means suppose you write 12 You write 12. So that itself is a constant. That itself is a constant. Okay. But you are not giving any identifier to it, or you are not assigning it to any identifier. Just exists 12. So that's why it is called as literal constant. Literal constants. Integer constants and floating point constants, which are literal constants, are just numbers. Are just numbers. You can write. So this is integer literal constant. So this is floating point constant. So the other constants are character constants, which are nothing but the single characters enclosed in quotation marks. D is the character here. It is enclosed in the quotation marks, single quotation marks. So it is a character constant. String constant means which is enclosed in double quotation marks. Which is enclosed in double quotation marks. So we can see the examples. These are some of the examples. Some of the examples. The integer constants can be represented in decimal, octal, and hexadecimal forms. So in most of the cases, we use only decimal things, but they can be represented in decimal, octal, and hexadecimal forms. See. So in decimal form, directly its value is written. So 123. Okay, it is a integer constant. In octal form, if you want to represent in octal form, the integer constant, it should be preceded by 0. It should be preceded by 0. Like this. So the same has to be represented in hexadecimal form. It should be preceded by 0x. So also the integer constants can be unsigned long and unsigned long. So you have to use appropriate symbol to differentiate them. You can see here this is terminated with U, unsigned. This is terminated with long, L, that is long, unsigned long. So this is about the literal constants. Floating point constants. Floating point constants are also literal constants. They can be represented in decimal and also scientific notations. This is the decimal notation with dot in between, and scientific notation which is written like this. Here E4 means multiply by 10 to the power of 4. That means 12.4 into 10 to the power of 4. 12.4 into 10 to the power of 4. So general form is this one, Mandisa E exponent. You have to write like this. So that is regarding the literal constants. So we'll discuss symbolic constants also. But before that, variables. What is this variable? A variable is an identifier whose value can change during the execution of the program. A variable is an identifier whose value can change during the execution of the program. So if we take a constant is an identifier whose value doesn't change during the execution of the program. Whereas a variable is an identifier whose value can change during the execution of the program. More comprehensive definition or more appropriate definition is a variable is a quadruple consisting of the name of a variable, type of the variable, address and value which is stored at that address. That means A variable will have a value, say some 20 or something like that. Will directly take value. So this will be stored at a location. This is stored at the location or address. Location or address. Okay, and then associated with this value or variable will be a type. Associated with it will be a type. And it will have a name actually. It will have a name. Okay, that means it has a name and an associated type. This name has an associated type which indicates the type of the value that is stored at this address. So all these combined can be taken as a variable. Quadruple consisting of a name of a variable, type of a variable, address and value which is stored at that address. So we have different data types. The variables of different data types are possible. And keywords cannot be used as variable names. Declarations. In C, the data type of the variable has to be explicitly stated. That means whenever you are using any variable, say it can be A, B, C or first number, second number, whatever it be, the data type of it should be declared or should be explicitly stated. So in some programming languages, suppose if we are using A, you can directly write A equal to 20 without declaring. But in case of C language, what you have to do is, the meaning of this explicitly stated means, C language you have to, because you want to store 10 within that one, what you have to do, you have to declare it as integer, and then you can assign the value, So if this thing is missing, if this is missing, compiler will generate the error message. So in some programming languages, you can do like this. For example, Python can do like this. Depending on the value, type of the value that is assigned to it, it will take that appropriate data type. But in the case of C language, which is a strongly typed language, so you have to declare the variable explicitly. And this data type cannot be changed during the execution of the program. Okay. So no implicit declarations. Data type cannot change during the execution of the program. How do you declare it? Okay, how to declare it? This is the syntax. This is the general syntax. So always try to note down the general syntax because they will help you initial stages. So after some practice, you need not remember these things. They are automatically come to you while doing the programming. But from the exam point of view, from theory exam point of view, it's better you remember these things. General syntax, data type, followed by space, followed by variable 1, comma, variable 2, dash, 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 depending on your requirement, terminated with semicolon. Suppose if you want to declare two variables, A and B as integers, then what you have to do? Data type. What is the data type? Want to declare them as integers. So data type is integer. So what is the first variable name? A. Second variable name can be B. So like this you can declare. Suppose you want to declare one as integer, a is the integer, and if you want to declare b as real or float, then you can do like this. You can do like this. So this is the data type. What are the possible data types? Basically, if you consider just basic data types for the time being, this can be integer, this can be char, this can be float, this can be double. But once you declare something as integer or character or float or double, whatever it be, you cannot change it again during the execution of the program. But of course, after running the program, if you think that you need the variable to be of a particular type, then you can change it. You can change it. But while the program is being executed, you cannot change it. So that means during the runtime, while the program is being executed, you cannot change it. So initial values can also be assigned. So if a is the integer and if you want to assign it value 10 during the declaration, then you can do like this. Okay, you can do like this. Constants can be also be declared. So we discussed 3 types of constants. Actually, we completed the discussion of only literal constants. But there are other types of constants also which are declared identifiers, similar to the variables, which are declared identifiers. That is what our definition is actually. Declared identifier. So if you want to declare a constant, then you can do it like this. CONST. The main thing is there CONST. CONST is compulsory. You should use it as it is. CONST followed by data type. It can be any data type again. It can mean char, float, double, or you can use the qualifiers also if you want. CONST, the data type, followed by valid identifier equal to value. Valid identifier name equal to some value. So the difference is here you are assigning to, in the case of variable, what you are doing, you are assigning a value. This value you can change during the execution of the program. So integer a equal to 10. Somewhere, if you consider this as a program only, so here you can write say some a equal to 20. So it is permitted. But when you declare it as a constant, say CONST, data type, that is int, where the identifier say a equal to 10. So we declare like this, and if you try to modify its value within the program, like a equal to some 20 again, a equal to 20, so you will get error message. It will result in error. So constant value once initialized cannot be changed, whereas variable value can be changed. That's why it is called as variable. What do you mean by variable? Which can change. When it can change during the execution of the program. Expressions. An expression is a combination of operators and operands, the evaluation of which results in a value. So evaluation of the expression results in a value. Evaluation of the expression results in a value. Evaluation of the expression results in a value. So what it consists of? It consists of operators and operands. Now, what are the operators? So, what are the operators supported by the language, C language? Whatever the operators that are supported by the C language. So, we will see what are the operators. For the time being, you can just assume plus and star as the operators that are supported by the C language, which implies addition and multiplication. So you have different kinds of operators. You can use those operators. You can use the different kinds of operators. And operands. What are the operands? Operands are nothing but the values. They can be directly in the form of values. They can be directly in the form of values, constant values. That means 10, 20, 30. You can use them. You can use them. And they can be variables also. They can be variables also. And the other aspect which we have not discussed but which is possible is function calls. There can be function calls also. So single operand can also be considered as an expression. So if you write just A, just write A is also an expression. So this is also an expression. Here you can see these two are operators. These two are operators. These two are operators. These two are operators, and these are the operands. These are the operands. Here you can see this is also an operand. This is also an operand. So A is an operand which is variable. B is also an operand which is variable, and 10 is also an operand, but it is a constant value. But it is a constant value. So the other possibility is we can write like this. So we have not discussed functions. So you can write say f of x. F of x. So that means A is operand variable, B is operand which is also a variable, but the other operand is function call. Function call. Now what exactly is the function call we'll see later. For the time being, you can just assume that whenever a function is called, so it will return some value. If it returns some value only, it should be part of the expression. Some functions doesn't return the value. So in that case, you should not use them as part of the expression. If a function returns a value, then you can make it part of the expression. Okay. And one of the good characteristics of expressions are which should be supported by the programming languages is some programming languages may violate this principle. So evaluation of expression should result in a value and should not change the values of operands in the expression as a side effect. As a side effect. That means, suppose if you write like this, a plus b star f of x should just return a value. Okay, should return a value, and a b and this whatever the value the function returns should be multiplied, and then they are to be added to a. Okay, a b values are not going to change. A b values are not going to change. Suppose here you write the function such that this function manipulates the values of a and b, and manipulates the values of a and b, then it will have a side effect. It will have a side effect. So it is difficult to read such programs, understand such programs. So what is recommended? The evaluation of the function should result in a value and should not change the value of the operands in the expression as a side effect. Side effect comes because of this function invocations, etc. Statements. C program consists of a sequence of statements. The C program consists of a sequence of statements. Statements can be classified into three types: declarative statements, executable statements, control statements. Declarative statements, executable statements, control statements. Declarative statements are those which provide information, which is required for the execution of the program, but they don't change any value. They provide the information. That means whenever you are using, say, dividing two values, two variables, say a by b. So a is 10, say b is 3. A is 10, B is 3. Now, how the system works is, if both A and B are real values, that is float or double, then the result of A and B is A slash B is 3.33. But if they are integers, then the value of A by B is only 3. So how the system or how the compiler is going to decide it? How it is going to decide it? So based on the information you provide, that is whether they are, you declare them as integers, whether you declare them as float or double. So declarative statements provide information which is essential. It is essential in case of C language. So executable statements result in some action. So it will produce some impact, some result. So 10 plus 20, 10 plus 20 executable statements. 10 plus 20 means it will add and it will result in 30. So some action will result. There are other types of statements called as control statements. Control statements, we'll discuss it as a separate chapter, but for the time being, what you can remember is control statements are those which control the execution of other statements. Control the execution of other statements. So in some books, they will be referred to as control structures also. Maybe that is a more appropriate name. But control statements are those which control the execution of other statements. So what kind of control you want to have? There are actually 3 types of control. One is sequencing. That means if you write the statements, say 1, 1, 2, 3 like this. If you write the statements like this, one after the other in this sequence, then first statement will be executed, then second statement will be executed, then third statement will be executed. So here 1, 2, 3 are not statements. They are representing the statements. First statement, second statement, third statement. So sequencing means the order of execution of these statements will be from 1, 2, 3. First 1, then 2, then 3. And then conditional statements, where suppose you want to decide whether 2 has to be executed or not based on some condition. Okay, based on some condition. Based on some condition. So based on some condition, you may execute some statement, you may not execute some statement. So condition will be there, a condition will be there, condition. Okay. So based on whether this condition, value of this condition, let us assume that true and false are the possible values. So if say the condition is true, you may want to execute say some third statement. So if the condition is false, then you may want to execute say second statement. So you should have a choice based on some whether some condition is true or false. You want to execute certain statements. Again, this need not be single statements. They can be group of statements also. So condition, based on some condition, statement will be executed. If the condition is true, some statement will be executed. So iteration or repetition statements, where you execute some set of statements repeatedly. Suppose here 1, 2, 3 are executed. Again, you will go to 1 and again you will execute. Of course, again there will be condition, or you will execute these statements fixed number of times, say 10 times, 1, 2, 3, 1, 2, 3, 1, 2, 3, like that 10 times. So repeatedly these statements will be executed. Okay, such statements are called as iteration or repetition statements. So remember here we are not going in exactly the same sequence. So because there is a lot of interdependency between the topics. We discussed constants, but we discussed only literal constants. Again, we discussed CONST based constants, and then we are going to discuss symbolic constants because there is interdependency between the topics. Dependency is there. We cannot follow it. For something to discuss, you should know something else. So little bit confusing, but I hope things will be clear at the end. So in C language, semicolon acts as a statement terminator and is written at the end of the declarative statements and executable statements. So this point in note down, written at the end of declarative and executable statements, statement terminator. Declarative statements and executable statements. A symbolic constant. A symbolic constant is a preprocessor directive, similar to your hash include. It's a preprocessor directive that allows a name to substitute for a sequence of characters. Substitute for a sequence of characters. The characters may represent just a numeric constant, a character constant, a string constant, and a multi-line test also. But the important point here is, takeaway point is, when the program is compiled, each occurrence of a symbolic constant is replaced by its corresponding character sequence. Each occurrence of a symbolic constant is replaced by its corresponding character sequence. Each occurrence. We'll see an example. We'll see an example program also. After completing this session, again we will go to the programming part. So maybe to the maximum possible extent, every theory session will be followed by a programming part. So symbolic constant is defined by writing has defined name test. Has defined, you have to use as it is. Name is the identifier which you can choose, and test is also which you can choose, but one which is going to replace the every occurrence of name. So for example, hash define x10. Okay, maybe let's use a. So after this, if you write statements like this, say some c equal to a plus 10, a plus some 30. So that means where here a is occurring, so every occurrence of a will be replaced by this 10. Okay, so like this throughout the program, wherever a occurs, it will be replaced. Okay. Symbolic constants make the programs more readable. Modifications to the program can be made easily, and modifications can be made in a single location. They reduce the overhead of function invocation. So there is always a trade-off between whether you have to go with the symbolic constant, or to be precise, whether you have to use macro or function. So macro is a multi-line test defined using a hash define. Macro is a multi-line test defined using a hash define, whereas function means you have to write the function. So there is always a trade-off. When the number of statements is limited, it's better you go with the macro. When the number of statements is large, you go with the function. So this is an example. Hash define C3 plus 5. That means hash define, the name is here C and the test is 3 plus 5. So you can write here anything. C, after C, you can write just 3 or 3 plus 5 or 3 plus 5, 7, 3 plus 5 start 7 minus 11, etc. etc. You can write in any complex test here. So C 3 plus 5. So here you can see D equal to C star C. That means because C is defined using hash define, so every occurrence of this C will be replaced by the test, that is 3 plus 5. So if you observe carefully, just for the time being, don't consider this one. Try to use your own brain or your own logic to tell me the value. Now as defined C 3 plus 5. D equal to C star C. What is the value of D? What is the value of D? So you may think that C is 3 plus 5, that is C is 8. Okay, C is 8. So D equal to C star C. So 8 star 8, that is 64. 8 star 8, that is 64. 8 star 8, that is 64. Is it true? Is it true? So what actually happens is every occurrence of C will be replaced by that 3 plus 5, and then the expression is evaluated. That means here D equal to C star C. So here D equal to C star C. D equal to C star C. Okay. Now what happens is code will be substituted for D equal to C. What is C? 3 plus 5. Okay, first occurrence of C. Next star, again, what is it? C. C is again 3 plus 5. 3 plus 5. This is the expression actually. This is the expression. And evaluation of these expressions in case of any programming language will follow two rules called as precedence rule and then associativity rule. That means the expressions are evaluated according to the precedency of the operators. So we'll discuss that precedency, but for the time being, the information you should know is star has, that is multiplication, has higher precedence than the addition. So then what happens? So first multiplication will be performed. Multiplication is in between 5 and 3. So 5 multiplied by 3, what is it? 5 multiplied by 3, it is 15. And then these 3 and 5 are added. This 3 plus this 15 will be there, and also here this plus 5. So 3 plus 15 plus 5. What is it? It is 23. It is coming to 23. So 23 is the correct value. So this is wrong. Okay, this is wrong. This is correct. This is correct. So these questions you will get generally in the competitive exams. The small one, but nevertheless, questions on symbolic constants. This is the typical question which you get in competitive exams. So the logic is every occurrence of the name is replaced by the test and then the expression is evaluated. That you try to remember. So directly here the expressions will not be evaluated. And here you can see, we can define a multi-line test also. We can define a multi-line test also. We can define a multi-line test. So it has defined multi-line macro ABCD. It is defined like this. So at the end of each line there should be a slash. If slash is missing means that is the last line means. So here there are 3 lines of test: C equal to A plus B, semicolon, D equal to A minus B, semicolon, and then this closing flower bracket also. Opening flower bracket is also there. Okay, opening flower brackets. What is the actual code here? The actual code. The actual code. Okay, if you want to continue to the next line, that line should be terminated with the slash symbol. Okay, now this is the code. This is the code. You do not write multi-line macro ABCD because here we are trying to pass the parameters. I have used it. So you can just write X also. Has defined X, the entire code. So in that case, wherever X occurs, this same code will be substituted. Same code will be substituted. Okay, this is regarding macros. Please remember, symbolic constants, macros is important. Enumeration. Enumeration is a list of constant integer values. Enumeration is a list of constant integer values. So that you have to declare, create using enum. This is the reserved word. We have to use as it is, enum, followed by, you can say this is the name. This is the name boolean, yes and no. This you are choosing. This you are choosing. So if you declare like this, that means S takes the value of 0 and no takes the value of 1. No takes the value of 1. So that means actually boolean can take the values yes and no. Boolean can take the values yes and no. Okay. So the other way of declaring it is enum boolean yes equal to 1 and then no. That means no takes the value of actually 2. So enum, enumerate. So it is derived from this enumerate. Okay. This sometimes you use these enumerations. So we'll discuss more comprehensive programs maybe later regarding this enumeration. The other one is escape sequence. An escape sequence is a sequence of characters that are used to represent some other characters which cannot be represented directly. That means if we have some characters, which cannot be represented, that we cannot type them directly. Okay, we cannot type them directly within the program. Such things can be represented by what are called as escape sequences. So an escape sequence is a sequence of characters, but it's not just those sequence of characters. Those sequence of characters represent something else. They represent some other characters which cannot be represented directly. So an escape sequence always begins with a backslash and is followed by one or more special characters. So these are the escape sequences that are supported in the C language. So if you observe, /n, we have already used it. Already told you /n. That means you want to go to the new line. That means you are executing, you are printing it after printing or before printing also, if necessary. After printing, you want to you want to make the cursor go to the next line. That means if you want to print anything, something else, then it should print on a new line. Okay, it's equivalent to pressing the enter key. So that escape sequence can be represented using /n. So some of these escape sequences which we will be using, most of the things we don't use generally, but /0 will be using extensively in the case of strings. At the end we'll discuss /0 and /t, sometimes we use it. Okay. So this is regarding enumerations and escape sequences. So Mangalamastu. Have a nice day. Have a happy day. Have a prosperous day. Thank you.